In this video, I'll show you how to find shadows of horizontal poles using a diagonal vanishing point, and it results in those diagonal shadows that you see on walls. And it's in my book, Ellen's Guide to Casting Shadows, on Amazon, and please remember to subscribe. I want to introduce you to the diagonal vanishing point, but let's first find the vanishing points that we talked about in previous videos. The building vanishing point is for structures on the building, like the roof and the stairs. The shadow vanishing point is on eye level, so it's for any shadows on the ground or the stairs, since they're both horizontal. The light vanishing point connects objects to their shadow, like the tip of the roof here to the shadow on the wall. And then the diagonal vanishing point is for shadows cast on the wall by poles perpendicular to the casting surface. So let me use a different color here. So here is a horizontal pole on the roof, and it's perpendicular to the wall, so it creates this diagonal shadow that goes to the diagonal vanishing point. Similarly, this shelf here is perpendicular to the wall, so it casts this diagonal shadow that goes to the diagonal vanishing point. Now, as you can see here, the building vanishing point and shadow vanishing point are on eye level. The light is above the shadow vanishing point, as we've talked about. And look at this, the diagonal vanishing point is above the building vanishing point and level with the light. Let's try to find all these vanishing points for this window. So we get the window vanishing point here by going from the corner of the window here and here. We get the shadow vanishing point over here by connecting shadows on horizontal surfaces, which would be the windowsill. Then we look for the sun or the light, and to do that we have to find, let's say, this window pane intersection here goes to a shadow right down here, and we draw a line up, and that would be where the light would be. And then finally we want to find the diagonal vanishing point, and they are on a vertical surface, which are these the sides of the window here, that are perpendicular to the poles casting them, which are the window panes. And again, we get this rectangle where the diagonal vanishing point is at the same level as the sun and directly above the vanishing point for the object. I now want to compare the light direction versus the diagonal shadows on vertical walls, where the horizontal pole is not foreshortened and when it is foreshortened. So in this first one, the bottom of this flower pot is horizontal, and the light goes through the front of it, and we see its diagonal shadow in back, and they do not overlap. In the second one, this pole, horizontal pole, is somewhat foreshortened, and this one is very foreshortened because it's close to eye level. And in this case, the light goes through the front of the pole, and the shadow goes through the back of the pole, and they're parallel, but they don't overlap. But when we go to the top here, we can see that the light direction and the shadow nearly overlap. The other factor affecting the light and the diagonal shadows is where are the two vanishing points. In this first case, the light is much further away than the diagonal vanishing point, so these diagonals on the wall are steeper than the light. In the second case, the light is nearly overhead, and the vanishing point for the diagonals is probably close by, so that the light rays are nearly parallel with the diagonal shadows on the wall. So here again we have the building vanishing point, the shadow vanishing point, and the light, and we can find the diagonal vanishing point using its relationship with the light and the building vanishing point. And so that gives us this diagonal here. And it reaches the ground here, so this is the shadow of this horizontal pole. So that makes sense. Now, if you can imagine the diagonal vanishing point coming down, well, the light has to come down too. And what would happen is that this would get longer and this shadow would get bigger, but this would still be horizontal because it's cast by this horizontal pole. In this slide, I show you two ways of using the diagonal vanishing point. This first one has light rays that are parallel and a horizontal shadow direction, so we don't know where the light is or the vanishing point for the shadows. All we know is the left vanishing point and the diagonal vanishing point. And this diagonal vanishing point is very useful if you have a lot of diagonal shadows on walls, which we have here, here, and here. And they're all from horizontal poles that are perpendicular to that wall. So all these, I guess they're balconies, are horizontal poles perpendicular to the wall. So using this diagonal, we can get all these diagonal shadows to agree with one another. Now in the second case, we have a shadow vanishing point, we have a light vanishing point, and we have an object vanishing point. And let's say we don't know where this diagonal should be. Well, we know where the diagonal vanishing point is if we know the other three vanishing points. So it will tell us that these diagonals on the wall should go to this vanishing point up here. I want to go over these shadows as a kind of review. So in this first one, we have this light triangle giving us intersection 1, and we could draw another light triangle here giving us this intersection, so that this shadow is cast by this horizontal pole. For this horizontal pole, we have light rays going through them, and then we need to establish seats on the casting surface through which shadow lines pass, and that gives us these two intersections. Then this horizontal pole casts this shadow, which is either parallel to it or converging. And to find number 4, we have to use this back vertical pole and find the light direction and the shadow to find number 4. And once we run out of intersections, then the shadow goes to the nearest corner. So that's the back, the shadow in back. Now in front, we have vertical edge 1 that's casting this shadow, which must be the shadow direction. When it intersects the light, edge 2 comes into play, and it casts horizontal converging lines here, and diagonals on the vertical walls here and here. And if we extended these diagonals, they would go to the diagonal vanishing point. I just started a new YouTube channel to teach art to kids 8 years old and up. And I go through some of the basics of art, hopefully in a fun way. And it's under Ellen's Art for Kids. And I have a book with the same name, Ellen's Art for Kids, on Amazon.